All right. So geometry. Okay. Hey guys, what did the acorn say when it grew up? Gee, I'm a tree. Okay. Troopertide Tuesday, the 18th of August. SWBA. What's that stand for? Okay, Schroeder. Students will be able to. You guys will be able to know and draw points, lines, segments, and rays. Section 1.1. So we did points, lines last time, and we also did planes actually as well. So we went over these undefined terms. We said, okay, well, here's how we model them, here's what it looks like, here's how we draw it, here's how we name it, the word symbols, and some facts about it, okay? And then we also went through and talked about, okay, they're considered undefined, and we drew some examples of these, correct? Okay? So now what we're going to do, okay, is we're going to go on to the next part, and we're going to talk about a few more terms here, okay? So we're going to flip the page here, we're going to flip the page here, okay? So we're on the second page of our notes, and we're now talking about a line segment, okay? A line segment. So it's similar to a line, but it's going to be a segment of that. So a model of it could look like that. That is a C and a D, a C and a D. So as in Cap'n Crunch and Doggo. Okay, C and D. Cap'n Crunch and Doggo. What?
Those are just two random things.
Well, I love doggos. That came
Cat and
out.
dog.
I didn't want to say cats because I'm not a cat person and I'm allergic. So
Then you should be allergic to dogs.
I hate cats.
what?
Then you should be allergic to dogs.
No, they're different.
They're two different.
So we draw it. Okay, if you guys remember, we drew the line with the arrows at each side, right? We drew the line with the arrows at each side. A line segment will be drawn with, remember the W slashes with endpoints. With endpoints at, okay, the at symbol, I'll just draw the at symbol instead of the word at. If you want to write out at, you can. And with endpoints at each end, okay? Makes sense that the endpoint would go at the end versus somewhere else. Okay? Move that a little bit just to limit the noise. But,
Yeah, sooner or later.
yeah. So, and we name it by 2 points. Same as a line. A line is named by 2 points or a lowercase letter. This one is just 2 points. You can't name it by a lowercase letter. So in words or symbols, if we were to talk about this segment, this line segment, okay, we could call it segment. You don't need to write the word line, just segment. CD, segment CD. Okay, or you could do. Segment BC. So once again, for this one, the order of the points doesn't matter, okay? Once again, for a line segment, the order of the points doesn't matter. We've seen that before with the line, and we saw it with the plane as well. The order of those didn't matter. So if we could put this in symbols, for segment CD, you can do your capital C, capital D, and draw a mini line segment above it. So you guys might remember that when we did the line, we drew a mini line above it with the arrows. Here, same idea, we just don't have the arrows on it because it doesn't go forever, okay? 1 second shorter.
When music's on that CD.
Fair enough. All right, and then, hey, but when I say 1 second, can I ask that you don't blur it out, though? Okay, thank you. And then segment DC could be a way we would put this in one, the second one in symbols. So a little segment above it as well, okay? Yeah, shorter.
DC superhero.
DC superhero, there you go.
CD.
Or DC talk field band, okay? So a fact about this one is it contains, a line segment contains all, my goodness, my pen is going bonkers right now, leaving trails. Contains all points between endpoints. It contains all the points between the endpoints. Okay, what is up, Ray?
So,
We're continuing on the second page of our notes. So, not only is the line segment to the endpoint every single point between, which is actually infinitely many points, okay? Questions on a line segment? Like I said, this first section, and really all of the first chapter is very definition heavy, so it's kind of a lot at once. It's kind of like drinking from a fire hose, if you ever heard that expression, okay? Kind of like drinking from a fire hose. The water just coming out really fast, and you're just like, whoa, it kind of gets blown back, okay? A ray, okay? Think maybe like a ray of light. Okay, so that's how it could look. That's how it could look. That's how a ray could look. This one, it's drawn with one endpoint. And what's it look like? It also has.
one dot.
That's the endpoint. And then one arrow. I'll say one arrowhead or one arrow, either way is fine. And by the way, this is my little and thing. So whenever you see me do, it's similar to a plus, but it's kind of like squiggly. That's my and, okay? So if I do this, that means plus. If I do this, that means an and, okay? So just so you guys know, it's just a little thing I do for my and. It just works for me. So I just want you guys to know, not to think, oh, it means plus, okay? So that's the difference there. If it's squiggly, loopy, then it's my and. If it's not, then it's plus. So you name it by, again, you name it by 2 points. You name it by 2 points.
We could do PTS.
Oh, for points. Yeah, so if you wanted to abbreviate the word points and write less, you could do PTS, okay, period maybe, and say, oh, that means points. Okay. In words and symbols, we could write out the word ray, PQ. Now, in this one, though, we can't do ray QP. We cannot do ray QP, okay? We can't do ray QP because it's very specific that P is the endpoint and it goes in the direction of Q. So Q is part of where it goes forever, but it stops at P, okay? So we have to clarify that it does not stop at Q. So when we say ray PQ, it's very specific. So on this one, the order matters. I'm going to put that even something that you guys might want to just put in all caps or underline in this box is that order matters here. Okay, the order matters. Okay. If we were to put this in the symbols though, for ray PQ, you could draw a mini ray. So one endpoint, one arrowhead. Now notice though, where is the endpoint? Which letter is the endpoint above?
Q. Or the P.
P. And where is the endpoint here? P or Q? P. So does that match? Okay, that's very important that it does, okay? The endpoint has to match that letter, okay? The endpoint has to match that letter, okay? So Q's over right where the arrow is, and Q's over right where the arrow is, okay? So it's very important it's like that. So that's our first one we've seen where the order matters on it. So a fact we know about it is it's part of a line. So it's part of a line that starts this was a pretty long one, by the way. That starts at an endpoint and continues or goes forever. In one direction. Ooh, that was a lot. So it's part of a line that starts at an endpoint and goes forever in one direction. So before the line went forever in both directions, the segment stopped on each side, the plane goes forever in each direction, a ray goes forever in one direction, okay? Okay, and our last one of these kind of terms, we'll learn about a lot more terms. The last one of these kind of terms for the day is opposite ray. Okay, is opposite ray. Pay very close attention to the fact that this dashed line and B are at the same spot. The dashed line goes through B, okay? Pay very special attention to that. It's very specific for a reason. Now what this one is if I took that dashed line away, it just looks like a line, doesn't it? If I took the dash line, the dash part away, it looks like a normal line. So what this is a line that basically got cut in half. So this dash line is saying that it got cut in half there. And so it now looks like two different rays. So if I were to cover up the left side of this, okay, pretend that actually covers it up, you can't see it over it. We look like we have ray BC here. Whereas if I cover up the right side of it, which this is actually doing, it looks like we have ray BA over here, okay, going the other direction. So it's two rays that head in opposite directions, okay? Now, when we draw this, it's drawn as a line that must have at least 3 points. Okay, drawn as a line that must have at least 3 points. So this one has to have at least 3 points for it to work. We'll talk about why in a moment. This one's named by 2 points per ray. So each ray needs 2 points. So if each ray needs 2 points, why do we only need 3 points? Isn't 2 plus 2 4?
You need that line in the middle.
Okay, what was that?
You need the line in the middle
What do you mean the line in the middle?
to separate them.
To separate them, okay? But if we're going to name it by 2 points per ray, what are you saying, Dayton?
Use the same point twice.
Yeah, use one of the same points twice here, okay? We're going to use B twice. So B is going to be shared. So if we're going to put this in words and symbols, okay? You can say, rays, both of them, rays BA and BC. You can say rays BA and BC. Okay, both of them. And notice we use B twice because B is the shared point. It's an end point for both of them. Okay, or we could write it like this with the symbols. BA, ray BA, and ray BC.
More common.
It is more common. Now, do you guys notice that ray BA actually goes from right to left? It starts at right and it goes forever in the left. But when we did it in the symbols, we went left to right, didn't we? Okay. We always write it this way. Where you put the endpoint first for a ray, even if we draw it the other way. Okay, so it can be drawn the other direction. We always write it with the endpoint first. Just a heads up there. Okay. If you really wanted to with ray PQ, you could have ray PQ look like this even. because it's still P going forever in the direction of Q, for example. Okay. Fact about this one, it's a lot shorter than the last one. Two rays that form a line. Two rays that form a line. They come together to form a line. So it's two separate rays that look like one big line. Because the endpoints are the same, and they're going exactly opposite of each other. Now question, since these together form a line, would that work if it was like this? Does anyone know if that could be considered an opposite ray?
No.
Okay, why not?
Because they touch.
Yeah, not because they touch here, but this opposite rays touch here.
It's two separate rays, but they aren't aligned.
Okay, they aren't forming a line together, are they? They're not
Forming
going in
an
exactly opposite directions. They're just going in different directions.
They're forming an X.
Okay, so they're just going in different directions. It's kind of making an angle there rather than forming a straight line. Okay, questions on that? So let's, we have a little bit more on this page over to the side. So over on the right-hand side, name the pair of opposite rays in this diagram, okay? Name the pair of opposite rays in this diagram. Raise your hand if you can help me try and name this pair of opposite rays in this diagram. Elizabeth. Okay, ray DC. And we're going to use the name with it, so ray, the type of thing. I'm going to put I'm going to default to the symbols because it's less writing. So ray DC, and what else? Hey, Elizabeth again? Yeah, and ray DE. Okay. And I know it's something we'll all have to get used to, but I'm going to ask that everyone says ray as well as that, so that way we don't think it's a segment, we don't think it's a line, because technically, we could call them, there's such a thing as a line DE and a segment DE here that are different, okay? Because the segment DE would just be this part, but the ray DE is all of this going forever, okay? So that's different. Ray, I just realized it's going to happen a lot in this class where you think someone's saying your name, but we're just saying the actual geometry part. Anyway. What?
I just said okay.
Okay. So I want you guys to try and draw ray QW. So try and draw ray QW on your paper. Okay? So draw what you think that might be. Okay? How you think it might look. So go ahead and try that. Go ahead. I don't know if you got it. Yeah. That's a good reason. Alrighty. So, how could this look? So we can describe it to me on how this one would look, okay? Blinking on names here. Let me look at, okay, writer. I'm gonna get these down, I swear, okay?
So you have the endpoint, and
Okay.
that's where Q will be,
Okay, endpoint's gonna be Q.
and then the line going that way, and then double E.
Okay, somewhere on that part of the line, right? Very good. Now, writer, does yours look exactly like the same angle as mine? Okay, but that doesn't matter, okay? So that doesn't matter the angle it's at. W could have been over here, W could have been here, 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 or where it is over here, okay? As long as there's an endpoint at Q, like you said, and then a line that goes out, and W's on that part, okay? Any question on this one? So just because yours doesn't look exactly like mine, you might still have gotten it correct, okay? Draw line segment AB, okay? Draw line segment AB. So I want everyone to try this as well. So line segment AB. So if you need help with how to draw a line segment, look at that table we just made on this page, okay, to help you out with that. Christian, can I have you help me with this one? May I have you help me draw this one? What? You can just kind of describe it, right? Yeah.
I just draw two segments with A and B flip.
Okay, so you do two. So just tell me one of them then for now.
A and B.
Okay, where do I put A and where do I put B? That kind of thing. Like, what am I writing here?
It's writing line segment.
Okay, so I'm gonna write line segment. Oh, you mean something else. Okay, what do you mean?
You're drawing a line segment.
Okay, how do I do that?
You draw lines with two dots at the end.
Okay. So dot at each end or just two at one? Okay, dot at each end, so endpoints. Okay.
Then you put A and B
Where at? Here?
on line segment. And
Okay, one on each or both are the same? Okay. Does it matter which one's which?
No.
No, it doesn't, okay? We got there, okay? Good work. So, line segment is straight line with endpoints. Capital A and capital B, one on each end. It doesn't matter which one's which. Okay? It doesn't even matter if this line segment's going perfectly left and right. It could be up and down, it could be angled, it doesn't matter. Because the order does not matter on a line segment of how we word it. Okay? Questions on that? Could we put arrows on this though and still be correct?
No,
No, why not, Schroeder?
that would be a line.
Because that'd be a line and not a line segment, okay? What example 6? This is really just a question to you. Would ray QW be the same as ray WQ? Would ray QW be the same as ray WQ? Think about that one for a second. Would ray QW be the same as ray WQ? If you're struggling with that one, maybe try drawing it out. Okay, maybe try drawing it out. Okay, what are you guys thinking? Does anyone have an idea on whether or not that'd be the same thing? Okay, Ryan, what are you thinking?
No,
Okay, no, and why not?
because the endpoint Q on one of them, and it would be W on the other.
Yeah, so they'd have different endpoints, wouldn't they? They'd have different endpoints.
They'd have different points in general.
Different points in general. So one of them would look like this, maybe. And the other one would look like this. Those are not the same thing. You can't just flip those around because of the fact that a ray has a specific stop and start on one side only. It goes forever on the other side. So one of these starts at Q, one of them starts at W. Whereas a line segment, whether or not this starts at A or B, it's just all about how you're looking at it. This one, doesn't matter how you're looking at it, it starts at Q, this one starts at W. Questions on number 6, example 6. Alrighty. Example 7. If line PQ and line RS are different names for the same line, if line PQ and line RS are different names for the same line, what must be true about the 4 points P, Q, R, and S? Okay? So if we have these lines, PQ and RS, but they're the same line, what do we know about those points that are all in those names? Okay, Elizabeth? They're all in the same line. That's exactly right. Okay, so we name a line by any 2 points on it. So if we're naming a line by any 2 points on it, and we know a line is named PQ, well then we know it has to have P and Q on it, right? And if we know that it's the same line, and it's also called RS, then we know R and S have to be on this line too. We know R and S have to be on this line too somewhere. We don't know the order of these, but we know they all have to be on the line somewhere. So, what must be true about them? Okay, they are on the same line. That has to be true. So because they're different names for the same line, has to be true. Any questions on how we know that? Alrighty. Okay. So I know this is a pretty long section, pretty brutal section, but we'll get in there, guys. Okay. So some things you're gonna learn about lines and planes and intersections. Okay, lines and planes and intersections here. Okay, not to be confused with planes, trains, and automobiles. Okay. Anyone know what I'm talking about? Planes, trains, and automobiles.
Yeah, don't forget about boats.
Okay. Boats that floats. Yes, can't forget about those. Okay. So lines can be this thing called parallels. Anyone know what parallel means? You don't know what parallel means. Okay? I'm going to call someone other than Elizabeth, okay, because she's been answering a lot, and Schroeder's been answering a lot too, and so is Ryder. Okay, Ryan, what does parallel mean?
Never touch.
They never touch. Very good. Okay, you must have had a good Algebra 1 teacher that taught you that. Okay? So, these parallel lines, they are in the same plane. This is something new to us. They're in the same plane, and they never cross. They don't cross or intersect. Okay, or touch is another way we word it. They don't cross, intersect, or touch. So something it looks like are those two. Now, are my lines perfectly drawn?
No.
No, okay, that's okay. You can say that. I won't take offense. Okay? Now, it actually looks like they might touch eventually. So we have a symbol that we put on these lines to help us know they're parallel in geometry, okay? Because we have artist error, okay? Because I'm no artist and I make lots of errors, okay? So we put these little arrow things on them in the middle. That little arrow thing on them in the middle tells us, hey, those two lines are parallel because they both have one arrow in the middle, okay? So these little symbols here tell us they're parallel, so go ahead and mark that down as well. Now you know how we have a symbol for line, a symbol for line segment, a symbol for ray, a symbol for all these things to help us not have to write out the whole word because we're lazy. We have one for parallel too. So parallel, our symbol for this is two slashes. And what do those slashes kind of look like? Do they look like they're parallel lines? Okay, so we try and keep things pretty straightforward in geometry here, in the sense of the symbol matches what the actual thing looks like. Okay, the symbol actually looks like the thing. Okay, so parallel lines, it's two slashes because they look like parallel lines. Okay, where have you guys seen parallel lines in nature, in the world? Okay, Schroeder.
Railroad tracks.
Railroad tracks, right? The railroad tracks never touch going down the side or in the middle. Okay, Kenny.
That piece of line. Like,
Oh, okay. Well, maybe think of another one. Okay, Ryan.
ladder.
A ladder, right? The sides of the ladder, okay? Or the rungs on a ladder, okay? Ryder, do you still have one, or do you take yours?
It's wrong.
It's wrong, okay? Christian.
Jet streams.
Jet streams, okay? Jet streams that won't touch each other. Yeah, that's probably a good thing. Okay. Okay, Kenny.
DNA.
DNA. Yeah, okay. They'll never ever touch. Okay. I like that. That's a good point. Okay. That's good.
They should never touch.
They should never touch. Elizabeth. They can. Okay. Yeah. Because sometimes trees don't always go straight, but some trees definitely do. Okay. What about in this room? Can we think of some examples even in this room?
Flash.
What?
Door frame.
The door frame. Okay. The sides of the door frame. Those hopefully don't touch, right?
The flag.
Okay. The flag. The stripes on the flag. Okay. Right, Tony? Yeah. Okay. Hey, Tony. What about the bricks beside you? Okay. Would the lines in those bricks ever touch?
Yes.
No. Okay. Hey, can you put your head up, please? Okay. Please do it anyway, though. Okay. I believe in you. Okay. Anyone else have another example in this room? Okay, the chairs, right? The desks. Okay, kind of lined up. Some of them are lined up more than others right now because of the Rona being weird. Okay. So there's lots of different examples of parallel lines. Okay, we could even come up with more if we were to take the time.
Your desk
Okay,
length.
thanks for taking that earbud out again. Okay. What was that?
Your desk length.
The sides of my desk or the legs of my desk. Okay. So now we're going to talk about another thing. Lines can be, and that's perpendicular. Okay, they can be perpendicular. Does anyone know what perpendicular means?
They
Okay, Dayton.
form a 90 degree.
They form a 90-degree angle. So these intersect in a very special way. These intersect in a special way, okay? So these are in the same plane. I don't know why that bell's going off, because that's not actually what's like.
It used to go off at 9:30.
So these are in the same plane, so we're going to talk about what that means, okay? And they cross at a 90-degree angle. So they cross at 90-degree angle.
Please disregard that now.
So these are in the same plane, and like Dayton said, they cross at a 90-degree angle. So it's a very special type of intersection here. What else is a 90-degree angle considered?
Right angle.
A right angle, okay? Does anyone know what symbol we use to show that this would be a right angle? These are parallel, or perpendicular, excuse me, Schroeder.
They form a little box.
You form a little box. And that means that they're perpendicular on the figure. Because once again, our drawings might not be perfect, so we're going to assume they're not. And we use that little box to show us, oh, that's a right angle. Now we also have a symbol, so you don't have to write out the whole word perpendicular. It looks like an upside down T. Looks like an upside down T. Okay, it's like an upside down T. And if I were to cover up the bottom part of those perpendicular lines, does it kind of look like that symbol? Okay, I think it does. Ian's saying it does too. Okay, thanks, Ian. I appreciate you backing me up here. Okay, so I need that. So it kind of looks like that if I cover up the bottom part of this picture, it looks the same. Okay, just without the box. Okay, where do we see perpendicular lines in nature or in this room? Okay, Schroeder.
Intersections.
Intersections of streets, right? Most of the time. Most of the time, some of them are, but almost all of them are. Okay, where else do we see them? Okay, Kenny.
Your window.
My window, right? Okay, Dayton. The walls, okay, like two walls coming together. So you're thinking, okay, yep. Okay, Schroeder.
Target sign.
Target sign?
Because it's a T.
Oh, okay, gotcha. So like the letter T. Gotcha. So in target. Okay, I thought you were talking about like the circle one. I'm like, no? Okay, that makes more sense. Okay. Any others real quick before we continue on? Alrighty. Arrowheads? I don't think so.
They're not like just the open arrow, like the full arrow.
Oh, okay. So you're saying like the arrowhead, like that?
Yeah.
And so like right here you'd see one, here you'd see one, here you'd see one, here you'd see one.
Square.
Okay, or a square, okay. So all sorts of things, okay? So lines can also be intersecting. Intersecting, they're also in the same plane. We'll talk about what that means in a second again. And these just cross. But crossing, little star here for a little note here, does not have to be 90 degrees. Okay? So if it crosses at 90 degrees, then these intersecting lines are also perpendicular. Okay? So intersecting lines can be perpendicular, but they don't have to be because it could be a different angle. So an example of these, I'm just going to draw any two lines that intersect, not at a right angle. Okay? And we don't have a special symbol for these. Just because it could look so many different ways. So we don't have any sort of symbol for these, okay, or any sort of marking because it's kind of the more general one where parallel and perpendicular are special. Okay, whereas this one's kind of the, oh, okay, well, if they're not one of those two, it's this. Okay. I actually don't think it's cold. I'm sorry you feel that way. I'm sorry it's cold to you. Or they can be skew. Lines can be skew, okay? So lines that are skew, they are in different planes. So these are in different planes. Everything else we said they're in the same planes. These are in different planes. And they don't cross. What other types of lines did we see that didn't cross?
Parallel.
Parallel, but notice that these are in different planes, whereas parallel are in the same plane. I said I would explain that later, now it's time to explain that, okay? So, if we were to look at this, it's also very similar to this box, okay? It's also very similar to this box, okay? Think about this here, this 3D shape, being alive in 3D right here on this box, okay? So that would be like this line up here on this box, okay? This line, we could say is a part of this plane as well as this top plane, okay? So this line over here is a part of this plane as well as this top plane, okay? Now does this line ever intersect this line down here? No, but they're not considered parallel because they're not going in the same direction even, are they? Okay? But they're in different planes because this line is a part of this plane on the side and this plane on the top. Where this line here that I'm touching now is part of the front and the bottom. So these would be considered skew. these would be considered skew because they're in different planes entirely. They're not even in the same part. Whereas this line up here, the one I was talking about originally, compared to this one beneath it, these would be considered parallel because they're both in this plane. Okay? Another way to think of that is this room. Okay? So if we were to think of the edges of the wall, okay, the wall is a plane, the floor is a plane, the ceiling is a plane. Okay? This little crease down here, this could be a line. Where these two planes meet, that could be a line. Okay, the corner there, you guys know what I'm talking about? Okay? So that would be parallel with this crease up here where these two planes meet, where this wall meets the ceiling. But it would be skew with that one up there above the American flag by Ryan and Landon and Ender. Okay? Back here, it would be skew with this one back here, okay? Does that make a little more sense by chance? I hope so. And hopefully it helps you kind of come alive a little bit, because otherwise this is really confusing, okay? Otherwise this would be really confusing.
I am confusion.
Okay, I am confusion, okay? So do you want to put that away, please, before I take it? Ooh, okay, so this is your warning, right? Okay, cool beans. And thanks for taking that out of the earbud again. Thanks for taking that out of the earbud again. Hey, take it out, or I'm taking it out. Thank you. I know, I'm the worst. Okay. So, planes. Let's talk about some planes, okay? Well, not like the airplanes, okay? We're talking about planes where things are at, okay? So planes can also be parallel. So just like with lines, these wouldn't cross. So they don't cross ever. They never intersect. So in this room, that'd be like the ceiling and the floor. We'd hope those don't intersect, right?
That wall and that wall.
Okay, or the opposite walls, okay? The front wall and the back wall, or the two side walls, okay? With this box, it'd be like the two opposite sides of the box, okay? Or the bottom and the top, or the front and the back, okay? So those would be all different planes that are parallel. They never, ever, ever touch, okay? Woo! We don't have a symbol for that, except for just our normal parallel symbol like we used earlier. We don't have any special markings that say that the planes are parallel on the picture. Okay. Perpendicular, once again, that means they cross. Oh my goodness. That is not the word cross. They cross at 90 degrees. And they cross at 90 degrees. So we have a little right angle logo there to show that as well. So not all the time would two planes intersect at 90 degrees. Sometimes they just intersect normally at a non-90 degree angle. But this wall, compared to the floor, would intersect at a 90 degree angle, okay? This wall with the ceiling would intersect at a 90 degree angle, okay? Over here in this bookcase, okay? This bottom would intersect with the front at a 90 degree angle, okay? Most of the time in nature, we end up seeing these. But if I were to have, and take this book, try that again. This book, and intersect it with this paper like this. Are those intersecting at a right angle?
That's 6
No.
Okay, no, it's some other angle, okay? It's some other angle, so that's not at a right angle, okay? So the right angle is a pretty specific one, but it happens to be the one we see probably most often in the real world. Okay? Happens to be the one we see most often in the real world, okay? So then we just also have normal intersecting ones where these cross, but it doesn't have to be 90 degrees again. Okay? Doesn't have to be a 90 degree angle again, okay? Questions on those? Okay. Okay. So planes are what hold everything else. The planes hold everything else. We talked about this a little bit last time, but this floor, think of it as a plane. The floor holds all these little points inside of it. Okay, anywhere you can poke a pencil down to the floor would be a point. Infinitely many in here, you couldn't even count them. Okay, but the lines in the floor, we can see those a little bit more. Okay, those pretend like they go forever. Once again, there's infinitely many lines in the floor. Okay, we could just keep going across and draw a pencil all the way across the room, and that's a line. And you couldn't even count how many you could come up with. You could not do it. Okay. Same thing with rays. They go in here. Shapes go in the plane. Okay. Because we have all these little squares in the plane right now. Okay, on the tiles of the carpet. So all these things go inside of the plane. Now we talked about how planes intersect. Okay. We talked about how lines intersect. Okay. Now two lines will intersect at a point. Two lines intersect at one point, okay? Very specifically, they intersect at one spot. It's not like they intersect at two different spots, okay? They intersect at one spot. And that would be right here, okay? So for example, we could call this maybe point C, just because I came up with C, okay? We can call them point C. Now, if something were to be a line, you know it's going to be straight, right? So we know it's going to be straight. If I were to try and make these two pieces of paper intersect twice, I'd have to fold one paper around, wouldn't I? Like now they intersect twice, but is this straight anymore? No, okay? So that's why two lines can only intersect once, okay? And they intersect at one point, okay? So lines intersect at the point, which is another thing we learned. It's something smaller than the line, okay? Because points make up the line. Okay? So two planes intersect at something smaller than a plane. They intersect at something smaller than a plane. Lines intersect at something smaller than a line. Lines intersect at a point. Two planes intersect at a line. Okay? So here is a line where those two planes intersect. That would be a line where the two planes intersect. Once again, if we think about it in the context of this room, if this wall is a plane, and if this ceiling is a plane, they intersect across this whole line, this crease, where they meet, okay, up there, they intersect the whole way across. It's not that it's just intersected like this one spot, but it intersects over here, and over there, and over here, and all the way over there. So this whole line is an intersection. The whole line is where they cross, like this box. This front and the back intersect on this whole line right down here. It's not just like right here they intersect, or right here, the whole line. Now, if we were to have three planes, okay, those will intersect. You can write this down right beneath it. Those will intersect at a point. Three planes will intersect at a point. Okay? Yes, Maria. So if we were to say, okay, this wall is a plane, that wall is a plane, and the ceiling's a plane. The only spot where they all touch is that very corner.
And that corner.
Okay? Not this wall. So this wall over here, and the side of the room next to the hallway, and the ceiling, the only spot they all touch is that one corner, that one little point. There's one spot where they all touch. Okay? Every other spot they don't. So they intersect at a point again. So just like here, front, side, bottom of the box, intersect at this corner right in here, just one point. Questions on that? Okay, I know this is a long haul, guys. This is our last page. Then we're done with notes for today. Okay, everybody stand up and stand next to your desk. Everybody stand up and stand next to your desk real quick. Okay, go from the ground and stand up next to your desk, okay? Okay? You guys have probably done this in PE a little bit, okay? You guys ever run in place in PE? You guys ever run in place and you're like, run in place, okay? Run in place. Come on, run in place, okay? Do some high knees, get those knees up a little bit. Okay? You guys ever hear of butt kickers? Okay, kick your butt. Trust me, those bad butt kickers. Come on. Tyler, come on. Alrighty, okay. Then we're gonna bend over, touch your toes.
I need that.
All right. Trish, anything else real quick, and then take a seat again, okay? In the blood moon, take a little brain break. Okay? We're going to talk about collinear. Co. Has anyone ever heard those two letters co before? Where have you seen that?
Co-pilot.
Co-pilot. So that means two
Co-pilot.
pilots flying together. They're working together. Where else have you seen it?
Co-worker.
Co-worker. Two workers working together. Ms. Haswell and I are co-workers, okay? Not that one of us is better than the other. Is that we work alongside each other, okay? So cooperate maybe means we're working together. So collinear means you're working. The co means together. Do we see the word line in linear? Okay. So that means they are going to be points. They're going to be points on the same line. They're going to be points on the same line. They're going to be points on the same line. So co means together, linear means line. Same line. So if you ever forget what this means, look at the word and say, oh, I've seen co before. That means together. Linear, oh, line. Okay. So they're points on the same line. So can anyone look at this picture and give me, oh, let's go with 3 points on the same line. Okay, writer.
S, Q, V.
Okay, points S, Q, and V are all on the same line. So an example could be point S, point Q, and point V. They are collinear. They're on the same line. Is that the only example we could come up with?
TSR.
Okay. We could also come up with points T, S, and R. So point T, point S, and point R. Now notice we use S twice though. That's okay. That's just fine. Okay. Now could we have also come up with more examples? Sure. Okay. But that's all we need for now. Okay. We also have non-collinear. What do we think non-collinear means?
Only one.
Okay, they're not on the same line. They're points that are not on the same line. Non means no or not. They're points not, I'm going to underline that, on the same line. Okay, points not on the same line. So looking at this picture again, can somebody give me 2 points that are not on the same line? Elizabeth.
Point
U.
U and point S.
Yeah, point U and point S. Oh, I like that you went back and did that. Point U and point S. And you went back and said, oh, point. Point U and point S. They are on the same line. What? Okay. Kenny, you want to give me a couple more?
Yeah.
Go.
Alright. Point B, point T.
Okay. Point B and point T. I think we had one. Got a longer walk this here. Point B and point T are also non-collinear, okay? Now, if I were to say point U, point T, I need to redo that T again. Point T, and point Q. Okay? Would we say that those are all on the same line or that they're not all on the same line?
Q isn't.
Okay? So as a group, are they all on the same line?
No.
No. So these would be considered non-collinear. Even though U and T are on the same line, this group of 3 would be considered non-collinear because they're not all on the same line together, okay? Does that make sense? But if I just said points U and T, we'd say, oh yeah, those are collinear. But as soon as I throw the other one in, they're non-collinear.
What was the third one? I'm sorry.
I did points U, T, and Q to show that even if you have 1 point not on it, they're non-collinear. Okay? So name the 3 lines that intersect at point A here. Did I miss the slide? Oh no, I go back to it. Okay. So name 3 lines that intersect at point A. So point A is up here. So we want 3 lines. They look like segments right now, but they're actually lines because it's how we just represent planes in two-dimensional space. Kenny, give me 1.
Point G and A.
Okay, line GA. Okay. Tyler, you want to give me another one?
B and A.
Okay. Line line BA. Okay, and who wants to give me that third one? Raise your hand if you want to give me that third line, Elizabeth.
Line DA.
Okay, and line DA. Those are the three lines that intersect at point A. And hey, what do we notice about these three lines as we look at them? What do they all have in common? The letter A, right? If they're going to intersect at point A, that means point A is on each of those lines. If they're going to intersect at point A is on each of those lines. And if we look it back up at a picture, GA, BA, and BA do all intersect at that same line. It's kind of like our box example, okay? Can somebody help me where planes GAB and FEH intersect? Planes GAB and planes FEH intersect. To help us with this a little bit, it might help us to look at it and say, okay, where are these two planes? So planes GAB, GAB, oh, so it's kind of the top here, okay? So planes GAB, and then we also have planes FEH. So FEH, oh, it's kind of the side, okay? So as we even draw those out, what line do they share? Okay, Schroeder.
J and I.
No, J is down here, and J is only touching one of the planes, and I is only touching one of the planes. Okay, Elizabeth. Okay, and so it's just going to be two letters because it's a line, but line GH, right? Okay, so the intersection is a line, and it's line GH, okay? So once again, something I like to do as I go through this is to say, okay, as I go on my first line and say, okay, plane GAB, GAB, oh, we're talking about the top, let me complete the plane. And then if I say, okay, plane FEH, FEH, just connect the lines and say, okay, well, I need to continue doing this plane here. And I can see the overlap right there between G and H. So that tells me that it's line GH is our intersection. Does that make a little more sense when I show it with the different colors? Okay, for some people. Okay. And there's no other place where these intersect. So, next question. Do planes GFA, and HBC intersect? So one thing I'd recommend to do is to draw this out on your paper. Okay, so go over and highlight it. GFA, so connect G, F, and A to know that we're talking about this plane over here on the side, as well as HBC, HB to C. Do those planes intersect? Kevin, what do you think? No, they don't touch at all, do they? Okay, so no. Okay, an explanation, how could we explain that? Okay, they're on two different sides.
They're parallel.
Okay, they're parallel. Okay, those would go. We're going to go with their parallel because it's a little more mathy, so to speak. Okay, but Kevin's explanation is good as well. They're on different sides. They don't touch. Parallel. Okay, they don't share any lines. Okay, or points. Kenny. Yeah, you have filled already. Yep. Okay, nice. Yeah. Okay. Anybody still need this page? Okay. Hey, that's good, good. You're learning. Co-planar, what do we think this might mean?
Two planes.
Okay, not two planes, but what did collinear mean?
Two lines on the same plane.
No. Collinear meant what?
Points.
Okay, 2 points on the same plane. 2 or more points on the same plane. Coplanar, they're going to be points on the same plane. So they're still talking about points, usually. Coplanar points, but these just means on the same plane. So it could be lines, I guess. I think about it more. So we have two different planes here. One plane P is going left and right. One plane R is going up and down. So can somebody give me 2 points that are coplanar? Okay, Tyler.
B and D.
Okay, points B and D are coplanar. Those are both in the same plane. They're actually in both planes, funny enough. Okay, Seth, or shorter?
G and D.
Okay, G and D, as in gosh dang it. Okay, point G and point D are also coplanar. Okay, those are in the same plane. Can somebody give an example of two non-coplanar points? Points that are not in the same plane. So not points not on the same plane. Tyler.
E and F.
Points E and F. Very good. Those would be non-coplanar. Okay? Oh, I said H, but as you said F. E and F are non-coplanar. Okay? Once again, what if I did point C, point E, and point H?
Still
That's not an H. Are those coplanar or non-coplanar?
not.
Non-coplanar, because H is not on the same plane as those. So they're not all three on the same plane. Yeah, shorter.
Point H and I.
Point H and I would be non-coplanar, okay? They're not in planes. Okay? Okay. Let's go to the very last part of our notes down here, okay? Does anybody still need this before I move on? Okay. This is probably like, I don't know if you'll agree with me, this is like our longest section all year.
Yeah.
Kind of awkward, it's our first one, but it's like our longest section all year. Okay? Which is why we did part of it the other
build
time.
on this all year long too.
What?
We build on this all year long too.
Yeah, we build on this all year, so it is important, but this is like our longest one just because it's definition after definition after definition after vocab. Whew. On this example, name the intersection of plane N, so plane N where all this is at, and line AE. So line AE, well, it looks like it's going through the line, so it'd be like a pencil or a pen going through a piece of paper. Okay, there's like part of it going on, part of it going underneath, part of it above it. So it's like a pen going through the paper is what you see when you see this dashed line here, okay? So where do those planes intersect? Okay, Elizabeth? Point B as in boy. Okay, point B as in boy is where those intersect. It's like where that pen's going through the paper at, okay? That dashed line means it's going behind it now. That dashed line just symbolizes going behind it. It's underneath it. We don't actually see that one, but we have a dashed line to pretend like we see that, okay? You guys ever see those like three-dimensional pictures of a cube where you have dashed lines? You guys know what I'm talking about? Okay, yeah. Okay, some of you are nodding your head, awesome. You've had art, but this is actually pretty great at doing what she does. And so that would mean that it's kind of behind it, but for the picture's sake, you see it. Name the intersection of line BC and line DC. So where do line BC and line DC intersect here? Okay, point C. Intersection of point C there. Okay, that's the one point that those two lines share. And that actually is in the same name, right? They both have it in the name. Do lines DC, or does line DC intersect line AE? Does line DC intersect line AE?
Yeah.
No.
It actually doesn't. Good job, Kevin. It doesn't. That's kind of a trippy one, isn't it? That's kind of a trippy one, isn't it? Okay? Because line AE is just going through the plane. It touches at that one point. Whereas line DC is in the plane. So even though it might look like an intersection because it's dashed, it's not actually in the plane there, okay? Woo! Any questions on that, guys? That was long, wasn't it, okay? Could I have you pass out the homework real quick? Thank you.
Hey, Mr. Go.
Yeah.
Oh, I'm gonna get this one.
Okay.
I wasn't paying attention.
I'll go back to it. No, but I do have a note to give you guys.
Why couldn't you make it 40? It's a lot now.
Sorry, I'll give you one more problem. Sorry about that. Okay. So Kenny will have an extra problem than everyone else. Was this the one you're missing, Kevin?
Oh, the
For next
Here.
Monday.
Okay. Hey guys, real quick note on this worksheet as Mr. Hazel's passing it out here, okay? So on number 8, it has an ID, an N, and an N. You can cross out that second N.
That's 7.
No, it's 8. Oh, it is 7.
Wait,
What?
7 or 9?
Seven and both 7 and 9.
Okay, so yeah, I know 9 does. Okay, you cross out the second one on 7. I must have moved and marked off word on accident somehow. Okay, anyway. And then on number 9, okay, just has up that little script letter up in the top right corner. You guys probably can't read it, it's weird. It's a U. The U is in ukulele. Okay, U is in ukulele on number 9. Okay, up in that top right corner. It's a script U, it's not a point. Okay. Now on numbers 4 through 9, when it says ID, it says identify it like as a part. Okay, so that's where you put this is a ray, this is a plane, this is the line, this is the segment. You don't have to write out like line AB, just put line. And then N is where you name it. So that's when you put the like the line BC with the symbol and everything like that. Okay, does that make any more sense? Okay, Dan, go from Lydia. Okay. I'll let you guys work for the rest of the period here, and I'll show a video for part of that as well, okay? But for now, you get to work it, and you guys feel free to listen to either here, okay? Once again, that is the longest section we have all year, which is kind of weird that it's at the start.
Don't we get at 10:30?
At 10. So pretty soon here.
What's the visual?
It's pretty neat.
I'll have to be
I'm borrowing that.
Okay, thank you.